All right, so when we're understanding the fundamental theorem of calculus, we need to understand, again, what integrals mean. And this is an AP question. We'll do two AP-style questions for you today, or with you today. You had a chance to work on number 11 here, so I'm going to go over number 11 with you. What this is saying is that the graph of y equals f of x that you see here, and I'll unfreeze my screen here for you so you can actually see what I'm doing. The graph of f of x is this sort of semicircular graph here, okay? It's a semicircle. It says that it's semicircular. Endpoints are these here. And it's asking for the value of this definite integral. Okay, so it doesn't give you the function of f of x. It gives you a graph. So again, we have to interpret an integral by looking at the graph. So what is an integral on the graph? Well, remember, the integral is the area under the curve between the lower limit of integration and the upper limit. So the integral of this f of x, this graph, dx, from 2 to 12. So from 2 to 12. So what I'm looking for is I'm looking for the area under the curve. Now this curve is actually below the x-axis, so that means we're going to have a negative area, but we have to find out what this area is right here. Okay, so this question is asking for this. It's going to be a negative area because it's underneath the x-axis and above f of x. Okay, so it's going to be underneath. It's going to be negative. So what we want to do is we want to, from the graph now, is literally just look for, try and find out what this area is. And the best way to do that is to envision two things. A rectangle right here. Okay, so this is going to be 10 by 6, right? So this is going to be 60 minus half of a circle. It's a semicircle, it says. And so we've got half of a circle here. Now, pi r squared over 2, what is r? The radius is going to be half the distance from 2 to 12 or 5. Does that make sense? So we've got 60 minus 5 squared times pi over 2. Or 60 minus 25 pi over 2. Now, that would be the positive version. So we actually have to have the negative version of that, which gives us this answer, which is C. So if you guessed C, you got that correct, okay? If you guessed D, you were really close. Really close, but C is the correct answer. Okay. So if we're finding this area right here, which you're not, but then that's half of pi r squared, which I guess would give you 25 pi over 2. Some of you might have answered B, or negative. That would be A, but C is the correct answer because it is this red portion that we're looking for. Okay. So now from a graph, finding integral. Okay, that's important. So now we move to exploring further the fundamental theorem of calculus here, the types of questions we've just been learning here, kind of part 1 and part 2. There's two different parts: finding an indefinite integral, but also finding the derivative of a integral, right? Finding the derivative of an integral. When you put those two together, these are the types of questions we're going to be looking for. So here's the derivative of an integral. Here are just the valuations of the definite integrals. So let's take a look at a question like this. It says this: pictured to the right is the graph of g of t. So this is the graph g of t. Okay? And the function f of x is defined as this: the integral. So f of x is actually the integral of g of t. The integral of g of t. Now, f of x is also the integral from g of t from negative 4. So here's negative 4 right here to 2x. Okay, so we're going to have to be given an x to be able to figure this out. So f of 0 is what the first question is asking for, f of 0. Well, f is the integral, and x is 0. So what f of 0 actually is, so here's f, this is what the definition of f is, and then I'm going to put 0 in for x. So it's actually the integral from negative 4 to 2 times 0. 2 times 0 of g of t dt. And this graph is g of t. So that's the first step, understanding what the question is asking for. And if you look at f of 0 and you look at f of x, okay, you just simply put in 0 in for x right here. And that's what I've done. First step, okay? Now, what is the actual value of that? Well, here's where we look at the graph. We aren't given g of t as a function, so you can't find the antiderivative and evaluate at 0 and subtract from evaluated at -4. Can't do that. What we're going to do is we're going to look at the graph. And of course, the integral is expressed also as the area under the curve and above the x-axis, or below the x-axis and above the curve, right? So from -4 to 0. Okay, so what I'm going to do is I'm going to look for this area here. So I've got area down here, I've got area up here. See that? Okay, but I'm going to split this up. I'm going to split this up, and watch this. This area underneath the curve is going to be a negative. And I see that I have a portion of a circle here, and I can make this a portion of a triangle, or maybe a half a square, another rectangle here, and a quarter of a circle. So what you have to do in this question is you have to literally calculate, using the graph, what the area is underneath the curve. An important thing to note, first of all, is that this negative and this positive, they're going to cancel each other out, right? Those are both half of a unit. So we have -0.5 plus 0.5 for this one and this one, okay? So this here, rectangle, is 2 by 1, so that's 2 units. And this right here is a quarter of a circle with radius of 2, so radius of 2. So pi 2 squared over 4, a quarter of a circle. So this is just equal to pi. Okay? So these two cancel out, and I have 2 plus pi. So this is 2 plus pi. That is number 1. Okay? And that mimics almost identically this question right here that you just had from the AP exam, finding the area under the curve. Okay? From A to B. All right? So let's move on. If you have any questions about that, chat in if you do. I'll pause and answer your questions for those of you that are online here. Number 2 is, again, this is now f of 2. Okay? So f of 2, again, this is f, which is defined by the integral. So f of 2 is going to be the integral from -4, because that doesn't change, it's a constant. And now this is going to be 2 times 2, so to +4. See that? Of g of t dt. And we're still just finding the integral. We're not finding the derivative of the integral. That's coming up. But we're finding the integral. So from the graph, I'm going to go now from -4. Well, I know what -4 to 0 is, right? So now I just need to add from 0 to +4. Okay? Well, this looks fairly symmetrical. So these two are going to cancel each other out. Okay? And, okay, well, what do I have here? -4 to 4. This is looking good. And so I have just double. Do I have double what I have there? -4 to 4. So we have, just double what we had over here. So -4 to 0 and 0 to +4. That's going to be double what we have, 2 plus pi. Or 4 plus 2 pi. All right, so those first two questions are important on the AP exam. When you're looking for an integral and you're just given the graph, it is the area underneath the curve. Okay? All right, and then we're positive above and negative below, right? Okay. All right, so now we get into fundamental theorem of calculus, derivative of integrals, because remember, f of x is an integral. So look at this. I'm taking the derivative of an integral here. The derivative of an integral. So the derivative of an integral, that's cool. So let's do d dx of this integral from -4 to, Now, you might want to find f prime of x first. I don't know. You might want to do that. So let's do that. 2x. I'm just going to leave the x in there, and I'm going to put the 1 in later, because this is what we've been learning, and this is pretty easy. Derivative of an integral with an x up here, right? Okay, so we know how to do that. This is g prime, g of t dt. So if I found this, what do I have? I have g of 2x times the derivative of 2x. So I actually have 2g of 2x. Okay, that's f prime of x. Now f prime of 1 would be simply a 1 in for the x here. So I have 2 times g of 2 times 1. All right, now I'll let that sink in for you a little bit, and I might, if you want, I can go over that again. I'm not quite done here, but what I've done is I've evaluated, or I've simplified the derivative of the integral with the x in there. And what do I get? I get 2g of 2x. You see that? The 2x goes in there, multiplied by the derivative. Now, when I put 1 into this derivative, I have 2g of 2 times 1, or g of 2. Final step here. What is g of 2? Well, g of 2. Okay, so where is our g? Where's our g? Well, g is what? G is the integrand here. Okay, so if I took the derivative of f of x, I would have g, right? So to find g of 2, we simply look at the graph here, because this graph is g of t. So g of 2, well, here's 2. And what is the value of the graph there? The value of the graph is 1. So g evaluated at 2 is equal to 1. So this is 2 times 1, or 2. Okay, let's keep going. We got a couple other questions here that are very similar. So now we need to find f prime of negative 2. Well, I know what f prime of x is, right? This is f prime of x right here. So f prime of negative 2, and again, on the AP exam, don't start from scratch at every little question. If you've done some of the work already before, you can use some of that work for the next question. So I know what f prime of x already is. I've evaluated f prime of 1. F prime of negative 2 is going to be very similar. So f prime of negative 2 is going to be 2 times g of negative, x is negative 2, so I got to multiply 2 times negative 2, so that's negative 4. Right? So g of 2 of x, and x in this case is negative 2, so that's g of negative 4. So what is g of negative 4? Well, I recopied this graph down here for you. So negative 4 is over here. This value right here, g of negative 4, is equal to negative 1. You see that? And my screen is paused. So g of negative 4 is negative 1. So f prime of negative 2 is 2 times negative 1, or negative 2. Okay. Okay, here's where it gets a little bit tricky, I guess. Now we're dealing with, and they'll do this on the AP exam, they'll have different levels within a question. A will be a little bit easier, B, C, a little tougher, D, pretty tough. They'll do that to you. So be prepared for that. But now we're talking about f double prime of 2. Okay, well, we know that a second derivative is simply the derivative of the first derivative. So what's this? Okay, let's see. First derivative, so f prime of x is 2g of 2x. Okay, so we could do this. F double prime of x. Okay, now let's look at this carefully. So this is a 2 times a function, and we have 2x as an inner function. So I'm going to take the derivative of the outer function, multiply by the derivative of the inner function. That's chain rule. We can do this, no problem. The 2 is kind of a constant, so we don't even really need to we could just leave the 2 outside, right? And focus on this as the outside function, and this is the inside. So I'm going to leave that 2 there. What's the derivative of g, function g? Well, it's just g prime of 2x. And the inner function, we have to multiply by the derivative of the inner function. Don't forget the chain rule, right? Don't forget the chain rule. Which is just 2. Okay? So what do we have? Well, the second derivative of x is 2 times the derivative of g of 2x, times 2. So that's, let me just write that as 4. So this is 4 g prime of 2x. Okay? Now, I hope you're with me so far. Just take the derivative of the derivative. But if I want to know this at 2, that means I have to put 2 in for x. No problem. 4 times g prime of 2 times 2. Okay, so this equals 4 times, now remember g prime, so this is g of x, this graph. What's g prime of x? That's the derivative of the graph. So g prime evaluated at 4 is the slope of the derivative of this graph at x equals 4. Okay, so this is g of x. G prime of x is the slope of the derivative, right? Slope of tangent, let's say. Slope of tangent. That's what I meant to say. Okay, so g prime of 4 is the slope of the tangent at x equals 4. So let's just take a look here. X equals 4. Where's the graph? Oh, it's down here. So here's the slope of the line. Now, if you said that this was undefined because 4 is an end point, I have to make that note. If it looks like this is an end point, then it's not differentiable. Therefore, the answer then would be undefined. But, okay, so you would be okay to say that, I think, because this graph is a bit incomplete. But let's say this graph actually continues on here, okay? It goes all the way through here and continues on. Then what we have to do is we have to consider what is the slope of this line right here. And you would literally take the slope of this. It's a linear line. So what is this? This is -1. This is to +1, so that's 2. And then that's 2. So the slope is -1. So g prime evaluated at 4 is -1. Everybody see that? It's the slope of the tangent line. And it's a straight line section, so it's just the slope of that line. So we have 4 times -1 should be -4. So f double prime evaluated at 2. Okay, so here's also my work for this, and again, if it looked like an end point to you, or if it stated that it was an end point, then you could say that this is non-differentiable there, because you can't take the derivative at an end point of a function. So you could say it's undefined. But if you understood this to be a continuation of this graph, which is reasonable, then you would have an answer of -4. Okay, so let's go back to my page I was just working on. So this is what we were working on here, and that is, yeah, that's a great representation of what you might see on an AP exam question. There's a little bit of everything in there. All right, so I hope that helps.